Hi, everybody. I'm Bob Bowman, Editor-in-Chief of Supply Chain Brain. I want to welcome you to this presentation called Unlock $20 Million in Savings with Superior Efficiency, Robotic Sortation versus Traditional Unit Sorters, presented by Berkshire Grey. One quick reminder, there will be an audience question and answer session at the end of this presentation. Audience members are encouraged to submit their questions at any time during the presentation by clicking on that Q&A icon at the bottom of your screen. Now, anyone thinking about replacing an end-of-life unit sorter or investing in a costly new one will want to hear how they can save $20 million or more in that initiative. And that's our topic today. We're going to discover how Berkshire Grey's robotic sortation system addresses the issues that an aging unit sorter brings to your operations. And we'll challenge some common misconceptions about unit sortation and reveal how next-generation robotics can deliver unmatched operating and capital expenditure value, productivity, and scalability, all without disrupting your current workflows. With that, I want to introduce my speaker for today. He is Noah Maynard, Vice President of Solutions Architects with Berkshire Grey. Noah and his team work closely with customers and partners to identify the most impactful use and optimal implementations for robotic fulfillment solutions. Noah brings more than 15 years of experience working in process improvement, warehouse operations, and supply chain automation. His past works include industrial engineering, program management, and systems engineering positions at C&S Wholesale Grocers and Symbotic. So with that, I want to turn it over to Noah Maynard for the presentation. Noah, take it away.
Thanks for that, Bob. Welcome, everybody, to today's presentation. So as Bob alluded to, we're going to be talking a little bit about unit sortation and some new and different ways to do it compared to traditional sorters. So let's just spend one moment quickly on what we're talking about when we're talking about a traditional unit sorter. A unit sorter for us, in purposes of this presentation, is a type of automated system that sorts individual units for products. It's designed to handle items of a specific size, weight, or shape within some preset parameters, design parameters. These unit sorters are commonly used across distribution centers and e-commerce order fulfillment operations throughout the world. And they typically work by transporting products on belts or trays to designated destinations where they will be, the goods will be deposited into those destinations for shipping or packaging. Which sounds efficient, right? And for a long time, that's the best way to do the job. And so that's why these things are prevalent in the market. But they do have some challenges, which I'll talk a little bit about. The first is that although they are more efficient than surely a purely manual operation, operations with traditional unit sorters are still somewhat labor intensive, particularly on although the induction can be somewhat fast, in the 1,000 to 1,200 UPH range. On the induction side for a unit sorter, there's still oftentimes a significant amount of manual labor, particularly at the bottom of the unit sorter where chutes or destinations are being cleared and packed. There's typically not a lot of automation in the takeaway space. They also have a fixed footprint. So these unit sorters, if you're familiar, I'm sure most are large, they're non-scalable infrastructure. And these big infrastructure pieces, they're fixed and they can't really grow over time. And so businesses can age out of their unit sorters as their business hopefully grows. These systems traditionally also have a single point of failure. And when I say a single point of failure, what I mean is downtime on an element can halt the entire operation. You can go from 100% capacity to 0% capacity immediately, and that's going to cost you valuable time and resources. They also, although they can handle a lot of merchandise, they are still somewhat limited in what they can handle. So particularly very oversized items. For example, if you look at our little picture here, there's a Bombay sorter. If an item is too big to fit on those two Bombays as presented in front of that person, that item would need to go through manual process. Also, a lot of smaller items, particularly items that roll, can be lost and have detrimental accuracy issues through a traditional system. So there's limited SKU handling, and that those items that can't be handled through this automation system either require downstream consolidation or a costly manual operation. So it's just adding a lot of cost to the operation, the fact that they have somewhat limited SKU handling. And the last, and I touched a little bit on this in the single point of failure bit, but as these systems age, they can become expensive to maintain and upgrade over time. And again, those breakdowns that you're guarding against, you're spending more and more maintenance to prevent against breakdowns because those breakdowns are so costly and disruptive. So although traditional unit sorters are a pretty well established platform, and they are prevalent in the market, they do have some challenges. And so, to the topic today, what we're talking about is if you've got an aged unit sorter and you're going to be tasked with either replacing that unit sorter to continue your business, is there a better way to do that to accomplish your goal? And that's what we're here to introduce or to kind of reinforce is that if you compare the traditional unit sorter methodology, the traditional unit sorter systems for similar capital outlay, you can gain a lot more. You can gain productivity, you can gain scalability. So, for example, there are systems in the market that have a vastly different labor picture. So I think about a traditional unit sorter, I could spend a similar amount of money to basically replace that sorter, or with a new system, perhaps I could have a 50% reduction in my labor required. Maybe I could do my job with a new technology in 50% less of space as a traditional system, giving you more flexibility long term, or increasing your building capacity because of better utilization of square footage. These newer systems, therefore, of course, can lead to a much faster return on investment than a traditional spend. They also can offer greater than up to 100% SKU coverage, depending on, of course, the industry and the merchandise to be sorted and things. But there's technologies out there that have a much better SKU coverage than a traditional sorter does. And lastly, these newer systems that I'm referring to, and we'll talk more about a couple examples of those, but they flex better with your business. They scale better with your business. So although a unit sorter traditionally is very fixed, you design it for one criteria, it's not very flexible over time as your business changes and grows. These new systems potentially are much more flexible, much more modular, and give you that value as well. So really what we're talking about is if you have to spend money because your sorter is out of life, should you spend that money and do the same thing you always have? Or should you spend that money and get, again, a much more valuable solution for your business overall? So before we get too much further in specific technologies, I do want to talk about a couple misconceptions in the market around unit sortation. The first myth is that you need a large specialized space. And that's not true. So robotic systems are more modular. They're more nimble. They can fit into existing brownfield spaces. They can fit into existing mezzanines. And so these systems are available to you without meaningful facility modification. So a lot of folks think, hey, I need to do a new sorter job. I need to do a lot of facility work to go with that. With some newer systems that are in the market today, those kinds of things may not be necessary. You may be able to have some savings and be less invasive for your building overall. Another myth is that the way these sorters are designed typically is that you need a destination per store or you need a chute per store. Basically, if I'm sorting to retail, there's this one chute in this sorter that's always my store in Phoenix or wherever. And if that store changes or moves, it's a pretty rigid proposition to move that around or to be flexible. With robotic systems, you don't need that. Automation lets you use software to move positions around automatically. It also uses some hardware to maybe stage or hold positions offline. So all that's to say is that, as a real world use case, one retailer is fulfilling 2,000 stores worth of demand with only 1,500 open destinations under their system. So it's kind of breaking the prospect that, hey, I need a chute per store. Newer technologies are much more flexible in that regard. One myth is that automation replaces all people. That may be true someday, but for now, automation can change your existing workforce's career trajectories. Robotic systems, automation systems let you leverage the folks that you already have in your building and use them more efficiently and reduce your dependence on hiring and reduce your dependence on folks outside of your building today. These automated systems, these robotic systems let you focus on labor optimization, and they can also, many times we find improved job satisfaction for employees. So automation doesn't replace all people, but certainly it enables you to do more with the people that you already have. Another myth is that new technology requires specialized maintenance. You're running your buildings today, you've got a maintenance staff today. If you're thinking about new technology, there may be a myth out there that I need a new workforce of maintenance staff who are higher skilled, have a higher level of skill to maintain new levels of equipment. And there's oftentimes that's not true. So you don't always need highly specialized unit staff for unit sorter. You don't need highly specialized staff for unit sorters today. Those people can often manage the exact same building with new technology, with robotic technology in the future. And that also can improve their job satisfaction as they have a new skill and they have new purview for their job, for their careers. Another myth is that traditional unit sorters can process most items. I think that exists because, again, they're prevalent in the market, and that's kind of what people think that they're processing. But I think there's a bit of an ugly secret that there's a lot of goods that can't go through traditional unit sorters today. These newer systems that we're referring to, they're able to handle the difficult items. They're able to handle the smaller items, the rolling items, and also the oversized items. Those oversized items, those manual items, they all require manual processing today, which is a higher, less optimized, higher spend, higher cost per unit for distribution in the manual process today. But with these newer systems with higher SKU entitlement, oftentimes the total operating cost can be brought down because you can get much more SKU coverage in these newer systems and therefore reduce your need for that costly manual processing and manual exception for the items that can't fit through your primary means of sortation. Another myth is that if you're today looking at a building and you're going to put a sorter in, I think the typical method is to say, I need to design for this system 10 years out because the sorter is going to run for that period of time. And so it's got to work at the end of that period of time. And I think the challenge with that is that you have to rely on those projections. You have to rely on a 10-year forecast. And of course, that's probably not accurate. I think a lot of things change in 10 years. It's certainly been my experience. But that's the best we often have. And so if you've got to make a decision today that lasts for 10 years in the future, that's a pretty brittle decision. And I think that can be really uncomfortable and sometimes even unwise, spending capital on a projection that's 10 years out so far in advance. Systems that are more modular, systems that are more scalable, let you grow that system with your business. So you can design for a much nearer, more line of sight design parameter, get the system running. And then as time passes and as you kind of realize growth and as you realize your business changes, these more modular systems let you kind of grow the system over time. They can basically give you a better design system in that 10-year horizon. And also in the meantime, they let you be more efficient with your resources, with your capital. Another thing that I would say is that automation, although it does seem scary, it does not need to be considered a risky proposition. One way that providers address this risk for their customers is that they do tailored simulations. These simulations let you validate your payback. They let you validate your use case. They often give really good insights into your ROI. They'll let you de-risk before you spend. And these simulations can all be done using real world data. So they can be pretty powerful. We're a visual species. The simulations also let us have a real visual sense of what a system would do in a building. And I think that's important because nobody knows buildings better than their operators. And I think being able to visualize the operation of a system in a building alongside other flows, other equipment, can be really powerful to build consensus, but also, reduce risk and really validate the impactfulness and also the efficacy and the validity of a solution. And then also, certainly, if you're thinking about simulation, these simulations all need to be backed by real world results. More accurate simulations are all born out of the right inputs, and the right inputs come from use in the real world. And so certainly if you're thinking about simulation to de-risk, you should trust simulations that have more real world basis than not. And so with that, I'm going to introduce one of these such technologies. This is the Berkshire Grey robotic product sortation system. I'm going to show a video here in a moment. And this is a technology that kind of meets those other needs. It addresses a lot of the concerns that we've been mentioning. It's a robotic system, it's newer technology, and it's highly modular. So let me run the video a little bit here. What you're seeing on screen is a deployment with 8 of the RSPS stations. There's 2 kind of networks of conveyor that run here. There's a network of conveyor that delivers supply containers, and then there's a network of conveyor on the bottom that is handling all the order containers. And you can think of this basically as a goods to person station or as a pick to light replacement. But in essence, the person is delivered a supply container and they are given an instruction to put goods onto these white cleated conveyors you see on the screen here. The SKU coverage of these cleats is very high. And so we're handling items in groups. We're handling multiples of items. We're handling unbagged apparel. We're handling boxes, as you saw, multis of these things. So it handles a wide range of goods very quickly. Now, you see here on screen this user instruction telling the operator here, take 2 units, put it to the left, take 2 units, put it to the right. And the system takes care of the rest. So they're addressing, up to kind of 140, 150 stores from one position without any walking, without any handling any supply containers, without handling any outbound containers. And so it's highly efficient, in this way. You see here too, there's automatic takeaway. So when the boxes are complete or the totes are complete, I should also mention we sort into totes. We also pick from cases, as you saw totes, but we automatically eject the outbound containers when they're complete. And then we've got some automation. We got really, really good box fullness or container fullness on the outbound side. So these things can be quite heavy. We've got automation to lift them out of those trays. And these caps that you just saw that that operator removed from that box, that lets us get really, really good fill cubically on these boxes. So really high throughput, very good labor proposition from that regard. Very dense footprint for the square footage, very dense throughput per square foot, as well as really good box fullness. So this is a system that I'll talk a little bit more about, but that meets some of the issues that we were talking about relative to traditional unit sorters. All right, so yes, those key issues. The first one we talked about was labor efficiency. Traditional unit sorters have this challenge. Compared to a traditional counterpart, the Berkshire Grey system that you just saw has up to a 50% reduction in labor required. The reason we get that is because although that traditional unit sorter can induct maybe 1,000 units per hour, 1,200 units per hour, these systems that you saw in the video often exceed 2,000 units per hour on induction. And they also offer that automated takeaway. So very powerful labor picture change by going through this route of automation versus a traditional offering. Another one is that it is highly space efficient. And so if you think about a like-for-like comparison from a traditional method in terms of the units per square foot, the system that you saw typically can operate in about half the square footage of a traditional sorter, which is, of course, critical for high-demand environments. And it's also critical when space is key in a building, as it often is, and as space is a constraint for your growth in that building. This can give you more capacity out of that building because you're doing more with what you have. Another point we mentioned before is that those traditional unit sorters have a single point of failure. The system that you saw these modules, right? You saw all these different components that are all moving in parallel. That's what you could refer to as distributed reliability. So what we say there is that there's no single point of failure. If one of those shuttle motors has an issue, you still have 59 other shuttles that are all processing at the same time. So instead of going from 100% throughput to 0% throughput, you've gone from 100% throughput to 98% throughput. So you're still able to process a lot of goods because of this notion of distributed reliability in this design. Very good SKU coverage, right? So nearly 100% of SKUs. So those oversized items, those coats, those big things that couldn't fit in that on that Bombay sorter that you saw a picture of, those can all be processed through this system. Basically, if it fits within that induction zone to the left or to the right of that operator, it can process through the system, including folding and all these things. So if you can get it in that cleat, the system will get it where it needs to go. It also regularly handles, those smaller items, those items that roll with a lot more accuracy and fidelity and efficiency than a traditional system. And the last bit, we touched on this a little bit so far, but the modularity of the design. So those building blocks, those stations, they're all scalable, they're all expandable. And that lets you, get into an operation, design for a nearer term parameter, and let your system grow with your business. That modularity, those systems can be added on during production without interruption. So very growable and expandable system because of that modularity. That also is a part of that distributed reliability that I mentioned. So to make this a little more real in terms of a specific customer case study, we had a customer who came to us with a notion that they had an end-of-life Bombay sorter. And they were thinking, this is a Fortune 100 retailer, so a very large company. And they were thinking about, is there a way to have a new way of doing this job that I used to do with my aged Bombay sorter, that I have less reliance on labor for order close, and I also have less reliance on labor for pack out. Order close and for induction. They wanted a system with better reliability. They had some heartburn recently with this old sorter that had a lot of downtime, and that downtime, again, brought their entire operation, the throughput of that building, to a halt effectively. So they wanted to eliminate that single point of failure, right? That was a big key. And they also wanted to increase their facilities capacity. This is a customer that, was growing quite quickly, and they were thinking about how am I going to get more volume out of this building in particular. They were looking at their network, and they wanted to defer the cost and the immediacy of opening a new building. They wanted to do that more thoughtfully. And so they're trying to, again, expand the capacity of the building that they already had. And so this was a success story with Berkshire Grey. So Berkshire Grey came in with the similar solution to the one you saw in the video, the same solution, just not that building. Instead of replacing the end-of-life Bombay sorter, they deployed Berkshire Grey. And what they achieved and what they run today is an operation with more than a 60% labor reduction compared to their manual or their traditional way of doing the job. That system that runs today has no single point of failure. It's a zero walking solution. So what we say is that there's less fatigue on associates, less strain on associates. The job to run one of these Berkshire Grey systems is easier than the job to run the traditional offering. The screen you saw on the video briefly there, the screen is the user interface is extremely intuitive. That leads to really easy adoption of the system and onboarding. We have customers who run these systems with temps. They show up on day one and they're already at full productivity, within a shift. So very easy to onboard new staff. But it also, conversely improves employee retention. So folks who've been doing this job for a really long time, they can actually, stay longer in their jobs, in their positions, and be more satisfied with their positions because they're working with a new system. There's less strain on the job overall, so it improved the retention of the employees that this customer already had. A couple quotes from the customer site. So one of the operators at Packout said that this is the best job that they ever had in their DC. Another customer, this was a selector. This is one of my favorite quotes. They said that the job is so easy now running the Berkshire Grey system that this is a person who's decided to delay their kind of effective retirement, delay leaving the building because their job got so much easier. They were able to stay in their position, to keep working their job, but also, the employer was able to keep, somebody who had been with them for a really long time. So certainly a positive story there. And because of the values that this customer has seen through this deployment, this customer continues to expand and roll out the technology across their network. They're adding more and more Berkshire Grey systems to more and more sites. So a big success story for the customer because of the value that they're achieving. So just to break it down, some of the messaging that we've shared so far, just in terms of numbers here, a little more specifically, we're going to compare a new Berkshire Grey sortation system versus if I needed to buy a new Bombay sorter. So if I think about the fact that I needed to buy a new Bombay sorter, I'm just going to get the same value that I always had out of it. There really isn't a return on investment. Versus if you think about the additional value that you would get out of the Berkshire Grey system and taking into account the investment that you would need to make, oftentimes we see paybacks that are less than a year, taking those things into account. And that's, of course, borne about by the fact that we have meaningful labor savings with this new type of technology as compared to just a replacement of a like-for-like system. That translates into, of course, a vastly reduced cost per unit, comparing 29 cents with the Berkshire Grey system versus 91 cents in how they used to do their job. But it also, importantly for them, grew their overall facility capacity. So now, for this line of merchandise, this customer out of this building is able to sort 67 million units per year versus what they used to be constrained at around 60. And then lastly, that Bombay sorter that we replaced had about 80% SKU coverage due to those constraints that you know well. The Berkshire Grey system is sorting about 97% of the merchandise in this building overall. So all those things stack up into a really compelling business case. This customer had to do something. They had to act. There was a compelling business event. And because they evaluated new technology, they're getting more value out of that asset than if they had just kind of reinvested in something traditional and replaced something that already was there. So some key takeaways before we go to a discussion that would lead from the presentation. So traditional unit sorters are limited, right? I mean, I think they're efficient, they're proliferated, but there's a new way to do things. But one of the limitations that exists is because of their ability to process your SKUs, and they're limited in their ability to grow. And then this notion I just kind of was hitting on, reinvesting in a traditional unit sorter that already exists just to maintain business continuity really doesn't have a return on investment. But you could gain labor and space savings. You could have a return on investment if you invested in new technology, such as a Berkshire Grey robotic sortation system. So these modern systems like Berkshire Grey's, they offer kind of the best of both worlds. They kind of give you the capacity that you need, but they also are more valuable in their return, and they really lead to compelling business cases. So it's a way to kind of future-proof your operation, for future-proof your fulfillment, be very flexible, long-term with very high throughput offerings. So the takeaway is that there's a different way to do things. If you've got a aged unit sorter and you need to replace, you need to do something different, you should absolutely go and see what's out there. So with that, I think Bob, I think we're due for a panel discussion.
Great. Thank you so much, Noah, for that presentation. I will now move into the panel portion of our presentation, in which I get to ask Noah a number of questions. But while I'm doing that, audience members should remember that will be followed by an audience Q&A. So if you have questions, please feel free to post them now, and by clicking on that Q&A icon at the bottom of your screen, and we will get to those as many as we can, time permitting. Okay, Noah. So in retail, as you know, you get a lot of variability with SKUs, especially when it comes to apparel. You get different sizes, shapes, materials. That really does make it tough. How does your system handle that variability, especially with things like clothing?
Yeah, the system that we're talking about is really differentiated in those use cases where you've got a wide range of less than case goods that you've got to sort, and again, in the retail space. So as you saw in the video, we sort apparel like unbagged jeans, coats. Of course, bagged is good too. We can sort those, but also health and beauty items, small cosmetics. They can all go through the same sortation platform. So there's no need to consolidate goods from different processes in the warehouse. The more you can get through one system, the cheaper the total overall cost. But just like with a traditional sorter, if you've got a unit sorter today and there's some items that need to go through manual process, there will probably be some manual process, items to be processed with this Berkshire Grey system that you saw. I mean, you shouldn't really trust, in my opinion, anyone who tells you that it's 100% end of the day, like no matter what, it's 100%, like, because that's just not really an informed, really, or analytical answer to your question, which is the reality.
No.
But what we'd say is that certainly because there's a higher level of SKU coverage, the quantity of goods that need to go through that costly manual process is going to be reduced. But maybe to just be a little more specific on some of the items that might be ineligible, something like a large down comforter that is only ever going to fit one unit in a box, we probably wouldn't recommend that you sort that through the system. You could, but it's really not that efficient because you're just getting one item in one box. So why'd you do that? Another one is the glass candle that's unwrapped, right? You probably don't put those through your Bombay sorter today. We wouldn't recommend that you put those through Berkshire Grey either. But the point is that, if you've got some manual handling today, you probably will have some manual handling in the future if you go down the road of a Berkshire Grey solution. But the point is that, you need to quantify the value of that increased SKU coverage, because you're going to have less of a costly manual operation for those exception items, which is going to lead to big cost reduction.
Yeah, such is the real world. How are the cartons routed to induction stations, Noah? Can you explain how a robotic sortation solution improves routing?
Yeah, sure. That's I think maybe unfortunately lost a little in translation from the video, what's actually happening there. So the system that you saw, this robotic system is kind of, it's an all-in system. What I mean is that all the hardware that you saw is a part of the system, but also there's a tremendous amount of software that sits behind what you saw. So the software is making all the decisions around where an outbound container should be placed, when I open a new outbound container, when I buffer, where I route a supply container to. So there's a lot of specialized software that's making that all happen. But specific to the question of routing, we're using something we call orchestration software to make sure that the right supply container is in the right place at the right time. And the physical architecture that goes with that, the conveyor that you saw, enables the software to be very flexible. So what I mean is that conveyor is often designed with things like early ins and early outs to kind of make sure that you can move goods around really efficiently. So it's hardware enabling the software with the sophistication to kind of do all that routing that you saw. And I would just, it's obviously a big topic and I could get passionate. I could go on for a little longer, but I guess what I would say is that there's a lot of experience within Berkshire Grey for the software that we built as a part of this solution. And I would say if a customer has a novel use case or they have more specific questions, I mentioned this in the presentation too, but we oftentimes will do things like discrete event simulations to really make that real for the customer prior to deployment so that they have confidence that, yes, we have software that's going to route things to the right place at the right time. It's not, I mean, it is a magic trick, but they can see the magic trick before they go deploy the system, I guess is how I would position the simulation. But
there's a lot of talk these days, concern these days about matching the box to its contents better because of concerns over sustainability, over packaging waste, over cost control, things like that. So
sure.
I'm curious then how your system optimizes box fullness across a wide range of SKU sizes and weights. Shipping a lot of air, as we say, drives up costs. So how does your system make sure that boxes are packed fuller?
Yeah, that's maybe another thing that was a little lost in my 2.5 minute video. But you saw this feature in the video. Hopefully, this thing we call automatic ejection, which is that when a box is complete, I use that kind of confusing word to start. We can push that box off the line, bring a new box in, so we always have our full box, a full complement of boxes or totes that we're sorting into, and send it down the line. But there's a lot of ways that we trigger that ejection mechanism. Certainly, an obvious one is that the order's complete. Push that off the line. We also have things to protect against boxes that are too heavy. If we're sorting goods, like hard goods, these boxes, cubic wise could get 60 to 80 pounds, and none of our customers want those on the road. None of our customers want their associates to be dealing with those in trailers and things. So we have the ability to kind of measure the weight of those boxes and then kick them out if they get too heavy. We also have things like, cut time. If a slow moving store hasn't seen a box in 3 days, hey, just send them what they've got. But all that's to say, so that I'm trying to highlight, there's a lot of different ways that we can decide that a box needs to come off the system. But in a push retail environment, and I think this is the core of the question you're asking, the most common way we do this is that we've got a sensor that shoots across the top of all those caps that you saw. I call that a cap, but those gray plastic collars that sat on the top of the box in the video, that kind of has that funnel mechanism on top. That's really kind of the trick to answer your question. So if you think about back to the video, that collar is meaningfully higher than the corrugate box. So as we're sorting goods into the boxes, we're basically sorting above the height of the corrugate, so we're getting up to the top of the cap, and that's where that sensor sits across the top, right? So we're sorting kind of above the height of the corrugate box. And as we're doing this, basically we're putting many goods in there. And because goods kind of come in different fashions, we got a really good mix of larger and smaller goods all within the same box. And so we're sorting these in. We detect that the box is full. We'll try to jostle the box actually using the conveyor on the line to make sure that we're getting the absolute most cube into those boxes as we can. Because certainly with our experience, with our customers, all of our customers want the fullest boxes as possible. That's a big reason actually that our customers, our repeat customers, is because they are growing, they are getting very full boxes. So we jostle the boxes, make sure that they get as full as possible, so that when we eject it off the line, I've broken that sensor at the top. I know that this box has been jostled and full. Like, boy, there's a lot of goods. And now if I think about apparel, that gets to that workstation that you saw in the video. The operator is basically smushing down the apparel or flattening it and closing that box. So the repeat customers we have, I would just say, actually, they build better box efficiencies into their ROI models. When they think about a building that they have manually and they think about if they're going to put Berkshire Grey in, our repeat customers are putting in an ROI element for fuller and fuller boxes. So it might not be intuitive, but it is certainly something that experiences that this system offers kind of a better density of packing compared to the manual counterparts, and our customers experience this every day.
So you're shipping less air, but you're also not overloading a box too, as you say, which is an interesting.
It's a balance, yeah, for sure. And I think that's part of adopting the system is really finding that balance for your operation. For example, how much overfull you get is able to be decided by the site, and where you want to set a weight parameter and threshold. That's all part of adoption of the system too. So yes, it's a balancing act, and we try to arm our customers with as many little knobs and levers to get the right mix of those features as they can.
Right. Okay. As you know, these sophisticated distribution centers feature multiple systems from multiple vendors. So I'm wondering then, how seamless is the integration of your robotic sortation with an existing warehouse management system, WMS, when you have several systems already in place?
Yeah, sure. I think I would highlight that the majority of, well, I shouldn't say that. A lot of the customers that where we deploy this are they're buildings that are full capacity wise. And so when I say that, this is obviously a brownfield environment, and there's all these processes in place that day in and day out for the last 10 years have all existed, and they're key to their business and they can't be interrupted. And so a lot of our customers, as I say, we are regularly integrating into existing buildings and doing so without interruption alongside kind of those existing processes. And I should say too that this is true of customers with enterprise WMSs, off the shelf WMSs, as well as customers with homegrown WMSs. At the end of the day, the information that the system that you saw in the video needs to operate is exactly the same as the information that the old systems needed. So oftentimes, from a WMS perspective, from an integration perspective, the systems will look like it's just a duplicate of what existed today. I need to know the store needs this item. I told my old Bombay sorter that. I'm just going to tell the same information to Berkshire Grey, and there's very little work to do. So in terms of access of data, availability of data, and integration, it's not a heavy lift.
Yeah.
But I would highlight though, as a differentiator here, these robotic systems, and certainly the one that you saw, it has the ability to emit a lot more information back to the WMS than those traditional systems. So it's certainly possible that there could be some work in the WMS to capture and use that new information that's now available. For example, timestamps, specific items in boxes, source and destinations. All these things can get lost in a traditional chute sorter or unit sorter kind of environment. I'm not really exactly sure which items got into which box because I'm kind of figuring things out. There's a little messiness at the bottom of the sorter. A lot more granular information can be available through a newer system like this. And the WMS, if it's able to, can consume that and pass on some value to the store. For example, I used to just get 8 boxes and I didn't really know what was in those 8 boxes. Now you can know ahead of time what's in the boxes, and that can give you some efficiencies either in your sort or getting goods back into the store. So there's a lot of new information with a more robotic, a more modern system that customers can take advantage of that can get even more value than just even within the 4 walls of the warehouse.
Yeah. So you're providing the information, but it is up to the operators and the WMS to do something with it.
Unfortunately, yeah, that's the other part of the coin. Yes, exactly.
Exactly. Okay, so from a larger perspective, though, how does the robotic sortation system help to boost overall warehouse productivity?
Yeah, so I guess maybe I'll answer that in 2 ways. So certainly it's increasing the overall productivity of people. The fact that if I compare it to a unit sorter, a person is just kind of putting one item on a tray at a time, maybe, for example. The fact that I can induct multis, I'm boosting my human productivity on the induction side. The automatic ejection is another big one too. You see a lot of unit sorters in the market where folks are there's a small army of folks underneath the unit sorter who are looking for a light that says, hey, this box is full. I've got to now walk over there, look in the chute and say, actually, it's not that full. I gotta smooth it down a little bit. And now I'm going to keep sorting this. So getting rid of all that reliance on all that labor underneath the unit sorter certainly is a big productivity gain. Not to mention, of course, things like the optimized box closing. But all that's to say, that's kind of, those are a little more detail on kind of the statement that we can eliminate kind of 50% of the labor required. It's because of an increase in productivity. But certainly, maybe more interestingly, it also increases the productivity of the building. And so if you've got limited staffing, you can't get enough people in the door, getting more units per hour out of the folks that you already have in the building. Everything I just talked about plays into that. But just again, on that square footage basis, if I've got, a big serpentine unit sorter that takes up, square footage, and I can't expand that because I'm building constrained, getting more units per hour per square foot out of the same footprint through technology like what you saw from Berkshire Grey or other robotics offerings, they certainly can improve kind of the overall warehouse productivity.
Well, let me ask you about some additional metrics, some kind of key performance indicators that maybe the system yields. What are the specific impacts on things like order accuracy, lead time, customer satisfaction when you're switching to a robotic sortation system? Can you provide data or examples of improvements in these areas?
Yeah, there's a couple different topics there. So, I'll try to go a couple one at a time. Accuracy is generally improved because, in a manual operation, things can kind of get lost going in the wrong spot, or an operator has to kind of figure out what the right place is to put something. And if they made a mistake, then that item is effectively lost. We generally find that accuracy is improved because the operator is placing things into fixed positions, right? It's not like they're trying to hit something as it goes by. As you saw in the video, hey, put it to the right. There's nothing moving there. I can put it to the right. It's kind of easy to do. So accuracy can be improved just because there's less sources of error. There's fewer sources of error in such an operation. Maybe answering the question, but in terms of lead time, I kind of lump that in with customer satisfaction. We can get goods out of a building faster, right? Everyone wants that. Improving service levels to customers, and that's all comes from the higher capacity of the system. Another bit that could feed in there too is, I mentioned a little bit here. Sorry if it's too much detail, but this dynamic nature of the system assigning goods to which chutes, to different chutes or to different destinations at a time. If I think of a traditional sorter, maybe a fast moving store has 2 or 3 chutes assigned to it. That assignment is done at a very fixed interval. And then maybe every month or so, I have to reevaluate and see what my fast moving stores are and what they aren't. There's a real impact on throughput there, right? Because if I have a fast moving store now that only has 1 chute, and I can't clear it fast enough, I'm going to be constrained. I'm going to get recirculations. Because the system is dynamic, it can see that actually it's not this store anymore that needs 3 open containers, it's this one, and make those changes in real time without a need for any human intervention. That can drive, the total capacity up because we're no longer constraints because we're so dynamic with how we assign those things.
Okay.
But I should say too, I'm riffing a little bit here. Those are pretty general answers. Part of configuring the system and designing it around a use case is really digging in on those things and quantifying them based on a specific use case. So I would just leave it. Maybe I'll leave it here. I'll try to. Our customers really, they realize and they often quantify those improvements in quality and customer satisfaction compared to traditional methods. So everyone's varies, but we do see a lot of improvements in those. But a specific use case is a specific use case.
You talk about not getting locked into a particular level of activity. Many warehouses, if not most, deal with peak periods, peaks and valleys of demand based on the time of the year. So how does your system handle peak periods with high demand variability and complex order profiles? And what is its capacity to manage seasonal surges without performance dips?
Yeah. So I would say from a design perspective, we are almost always building the system to hit more, with enough capacity for peak from a throughput basis. But part of the software and the value of the software that I mentioned is that it lets you use that order allocation software that I mentioned to right size your operations for an off-peak environment. So hitting peaks is inherent to the design itself. I've got enough throughput in the square footage with these systems available for peak. And then the software lets you kind of right size your labor picture. So what I mean is, at peak, you staff all your stations, maybe, for example, because I want all the throughput that I can get. But off peak, maybe I only need 60%. You can only, if you've got 10 stations, I could staff 6 of them. So I've got 60% because that's just my volume of the day. And the software will manage, getting the goods to the right place at the right time. So the software kind of enables you to right size the labor picture for off peak. And the system itself is typically more than capable of handling the peak volume. So a little, okay. I hope that helped, but certainly.
Yeah, that's good. At this point, I do want to shift over to audience Q&A because we do have some very good questions coming in from the audience. And even as we are answering these, please feel free to continue to submit your questions by clicking on that Q&A icon at the bottom of your screen, and we will get to as many of your questions as we can, time permitting. Okay, Noah, this is coming out of the audience now. This question is, what type of MHE, I'm assuming they mean material handling equipment, is commonly used for picking with robotic sortation?
What kind of MHE is typically used for
material handling equipment is commonly used for picking with robotic sortation? Is that clear? I mean, some of this is already material handling equipment. Basically, it's all that.
I'm not trying to. Yeah, I don't really follow that question, Bob. To be totally honest with you.
Okay.
If you follow it and you can help explain it to me, I'd be happy to.
Well, I'm not the questioner, so I'm not able to to elaborate on what they meant by that. But why don't we move on to the next one then? And this is as follows: can a robotic sorter manage packing rectangular eaches in the same shipping carton to maximize cube?
Yeah, so certainly, if we're dealing with purely rigid goods. So I've got a big box that I'm sorting goods into. I'm putting all these little rectangles in it. There would be some labor associated with, getting the right packing there. So certainly what I would recommend is, looking at the labor picture there, right? Like looking at the labor that would be required, doing a, kind of industrial engineering study on, hey, the goods will come out of the system in a certain configuration in a box. They need to kind of be reconfigured, and that should play into the overall labor picture of the system, right? Like if that's more costly than the savings elsewhere, that's probably not a good use of the technology. So I think it probably depends a little on the use case, but having a system that comes out with the same configuration, with that nice tiled presentation of rectangular items in a big box, absolutely possible. I would just want to make sure that it's a good use of labor to get it out of that system in that configuration, that you're getting enough kind of other savings that cost is worth it.
You talked about system redundancy, which keeps one little piece from breaking the whole thing down. It made me think about those Christmas lights where one bulb goes out and the entire string is dead. Not the case here, obviously. But this questioner is saying, can you please talk about the uptime of your system? Just generally, I guess.
Sure. Yeah, that's a question a lot of folks ask because downtime is a major issue, right? Especially at peak. As I kind of tried to mention before, the Berkshire Grey system is really designed with this in mind. The modularity, the fact that those stations can all operate independently, it enables a high uptime, right? So again, like I kind of mentioned, if one shuttle's down, I still might have, for example, 98% of my total capacity. So the uptime, I think if you think of it in that context, if I think about like if I'm down, I'm processing no goods. If I'm up, I'm processing goods. You should think of the uptime effectively as 100%. Right? Yes, you will have some blips through the system where one component is down or needs maintenance or whatever the situation is, needs an intervention request, but I'm still moving so much volume through the system that you're still able to process a lot out of your building. So the uptime is high, and I would think it's a different paradigm than kind of that single point of failure. Again, effectively approaching 100%, but well, yeah, I hope that answers the question.
Yeah. You mentioned earlier about the advantage of not needing the myth of needing special maintenance does not need that, but maintenance is always an issue anyway for every
Sure.
kind of system. Questioner asks, could you please address typical maintenance activities and costs that can be expected from this system?
Sure. Those systems that you saw, there's not that many moving parts. So you saw the video, it has some conveyor, and then it's got these moving parts, these slides that you saw going around, and a couple of different types of conveyor. We find by and large that, if you have staff today that is maintaining conveyor, they will be the same staff that maintains this new system. The new tasks that you saw basically are adding grease to motor ports, which, maintenance staff existing in buildings are more than capable of, and kind of doing wipe down of those slides and making sure that things are clean. These are all tasks that maintenance staff do today. So when we're building, our ROI models and we're looking at the total cost of ownership for these systems, the vast majority of the time, they're going to take staff that they're already paying today in maintenance, and they're going to pay the same staff and to do different maintenance with the same skill set. So it really is, an apples to apples kind of a situation from a cost and maintenance skill set point of view to maintain those systems that you saw. Again, really a lot of the magic kind of comes in the software. But from a maintenance and on-site point of view, it is electromechanically pretty simple.
Can you speak to the time it takes actually to install the entire system in a warehouse, whether brownfield or greenfield?
Yeah. In this business, we all know it's all kind of built around peak. So that is that's built into many project schedules. But I think, I would leave the group with the impression that from the time that we get on site to the time that we leave site, it's kind of in maybe the 3-month time frame. Size of the project really matters a lot. Install location matters a lot. If we're bringing goods up onto a mezzanine, that might take a little longer. So there's some variability here, more than maybe just giving a rote answer of 3 months. But it is pretty quick. It is those systems that you saw are all built off site. They are brought on site and kind of just stood up and integrated alongside conveyor. So in terms of the installation task itself, it's pretty straightforward. And I should also mention too, from a facility point of view, there's not a lot of facility upfit needed. If you can install conveyor in your environment, in terms of the levelness of your floor and lighting and all these things, you can put these systems in that environment. So there's not a long lead time for facility prep as well, if you're considering putting one of these systems in.
Thank you. Are these sortation bins and collection bins configurable to the product type? In parentheses, he's saying garments on hanger versus wallets, that kind of thing.
Yeah. I want to know more about what that questioner is use case is, but certainly,
Mm.
yes, we have many different outbound container sizes. Part of the trick, not the trick, but part of the design phase is kind of understanding how many boxes will fit in the station, what the size of that box should be, how it aligns to their SKU set. It's kind of doing this intersection kind of analysis of how much SKUs I want to cover versus the box size that I want to have and all these things. But certainly processing goods like garment on hanger, no problem through the system. Processing wallets through the same system or through its own system, that's okay too. So,
Mm-hmm.
and yes, the outbound container is configurable, can be totes, can be boxes, and so yeah, we're a lot of
Okay.
flexibility there.
Question is, how future-proof is your technology? Can it evolve with advancements in AI, machine learning, predictive analytics to stay ahead of future demands?
The system seems pretty physical, but as I try to illustrate, the software really enables the robustness and the variety of use cases. So the software is always getting better. The software is always getting smarter based on an ongoing understanding of a customer's order profile, a customer's use case. So the system is also, I should say, future proof from a hardware perspective. It's got the ability to expand. It's got the ability to do component retrofits if there's newer versions of things. So software wise, hardware wise, certainly it is can be very dynamic. It can change and evolve with the business over time. So certainly future proof in that respect. And then the artificial intelligence is a certainly we could have a whole webinar on that.
Mm-hmm.
But there's a lot of software built into our solution. It's not a buzzword. It is kind of an experienced, real thing that drives a lot of value in our system. So we leverage that as well and use our systems again to be future proof.
Especially if it ties back to what you were saying earlier about the amount of data that comes out of these systems now. The AI seems to be like an obvious play for managing that data and helping operations to interpret it and make use of it. So thank you for that. Well, I have to say, unfortunately, we are just about out of time. Noah, I have time with one more question, and here it is. Get ready. As you're taking this new information in, how do you know it's for you, if it's for you?
Yeah, I think the biggest takeaway that I would want the audience to have is if you're thinking of investing or if you're thinking of reinvesting in a traditional unit sorter, you owe it to yourself to just pause and to just make sure that you look at alternatives. There's new technology available with significantly better and different value propositions, with a better long-term use of labor, a better long-term use of space. Even things like box fullness and shipping costs can be improved. So if you have to spend money to replace an old asset, investing in new technology to transform your operation into something better, should absolutely be considered. And then I just as a side, I think when you factor in the additional value it can bring, the Berkshire Grey system, is such a system that could offer that really compelling payback and a really strong long-term value proposition. So if you're wondering if this is right for you, I guess the first thing I'd say to the audience is you should educate yourself on what's out there. Of course, Berkshire Grey is happy to talk about specific opportunities, but I would say importantly, don't take it from us. You should ask around in the market, be better educated on new offerings, and see if they're good for your current project. And I also say, even if you don't have a current project, being better educated will give you a personal competitive edge that you can bring back into your organization. So you don't just need to take our word for it. Certainly companies like Honeywell, companies like True, they are also offering robotic solutions like those from Berkshire Grey to the market from those companies, those integrated partner companies, alongside traditional unit source. So I think that in itself is a good indicator that folks should be better educated on what's out in the market and know that it is shifting towards solutions that have the potential to offer a lot more value for customer use cases.
No, thank you so much for this fantastic presentation. It's so timely given the needs of warehouses and distribution centers for cutting edge technology to help keep pace with what's going on out there in customer demand. So thank you very much for that. And thank you also, audience, for your attendance and for your great questions. Very much appreciated. Here is an ebook that you can download, Berkshire Grey Robotic Sortation as an Alternative to Traditional Unit Sorters, exactly what we were talking about today. You can scan that QR code right now, or if you're unable to do that in the remaining few seconds of this presentation, that will be sent to all attendees of this webinar. Everybody, once again, thank you so much, Noah. Thank you, audience. Everybody, have a fantastic day.
Thanks, Bob. Thanks, everyone.